Now we're recording. All right. Okay, so first thing I have to go over today, because I'm not super well versed in earth science, I am going to pretty much be reading off the list, just going. I will try to answer your questions as best as I may. If I cannot answer them, feel free to email me something, or I'll try to email your professor and see if they can answer them. Okay, so first thing we're going to do is we're going to look at the syllabus highlights. And essentially we're just going to go over it. It's very self-explanatory. I don't think any of you find it super difficult or anything like that. I did notice that some of the events here are going to be kind of interesting, so we'll go over that once my computer decides to load back up. Okay, so 600 points total with no options for extra credit, according to this professor. Now, I'm going to go ahead and I would be safe and assume that if the professor says no extra credit, assume that they're being serious. So do your very best on each and every assignment and try to get it as best you can. So moon phase observation project is probably one of the bigger chunks. It's worth 100 points of the 600, so it's 1/6 of your grade. That's basically a letter grade. This exercise is a 30-day project in which students will observe phases of the moon and log its position in the sky along with the times of observations. So it'll be 60 total. Project begins on week 1, ends on week 6. You can check the course page for details. You must begin and end the assignment as scheduled. Question to the class, has everyone been able to pull that up?
I haven't tried.
You have not tried? Okay, well, you might want to try soon.
Yeah,
So,
I'm an underachiever in case you didn't know. Also, Teddy, do we start it this week? Does it start this week?
It does. Yeah,
every day?
You have to start it by Friday every day.
Every single day?
You have to observe it 2 times a day, every single day.
Every single day for
every single day.
How do we know?
We'll be going over that a little bit in this class, but yeah. Okay, so our second part, quizzes, were 70 points. So it's not as important, but again, I would go ahead and try to do as well as you can. 7 quizzes total, 10 points each will be administered weekly, 15-minute time limit, 5 multiple choice, 5 true or false questions. Quizzes are based on the assigned articles only. So that's real important. If it's assigned articles only, that means you don't need to use outside sources. You don't need to freak out too much about having to find other stuff. It will be on the article. Closed book, helps of any kind may be used. So again, keep that in mind. Make sure you've done your reading and your study. Textbook checkups, 70 points. Checkups, each worth 10 points will be administered weekly. 15-minute time limit, 10 multiple choice questions based only on assigned textbook reading. I'm not sure exactly what that is. I'm assuming that's another quiz type thing. Yeah.
That's amazing.
Yeah, that seems right. It seems like there might be. So, go ahead.
They're short, so it's not.
Okay, so it's not going to be, all right. Seismic activity project, 60 points. This project involves generating a table of all global earthquake events of magnitude 5.0 or greater during 10 consecutive days. The project will begin on week 6 and it's due week 8, so it's only a 2-week project. Okay, check course page for details. We'll probably be getting into that around week 5 or 6. We'll be looking at that, so we're probably not going to worry about that this week. All right, 2 more things, sorry. Okay, exams, 200 points. Midterm exams week 4, final exam week 8. That makes sense. Covering textbook, reading, PowerPoint presentations, plus any supplemental materials posted on the course page. Information from the quiz articles will not be on the exams. I'm assuming is what that meant. 1 hour and 15, including 22 true or false questions, followed by 30 multiple choice. He really likes true or false multiple choice, which is good for y'all because you don't have to worry about filling in the blank, that kind of thing. So, provided you're studying, it'll probably be like a common sense thing. Just work real hard, you should be able to catch it. Again, closed book. So I've noticed a repeat of this several times. So this professor really does not want you to use open books. Some professors are different, they do, some don't, and that's totally fine. But just keep in mind, if it is closed book, be very studious and do your best to try to take notes and essentially do your best to retain the information. Okay, finally, threaded discussions. 5 threaded discussion posts worth 20 points each. Initial post 11, due Thursday 11:59, and must be 3 paragraphs. 3 paragraphs, 3 replies, each 1 paragraph due Monday following the initial posting. That's not too much. Usually reply discussions are 2 to 3 paragraphs, and if you're actually, I'm assuming he's going to let you kind of include opinions as well as just straight up analysis. So I would think that should yield itself to a pretty easy set. But again, each one of these, if they're worth 100 points or whatever, let's go whole letter grade. So basically, do your best in all of them. You should be fine. I don't foresee any major problems. Alrighty, next thing we're going to do is go over. Any questions, by the way? Curiosity? Okay. We're going to move on to our next thing, which is the assignment schedule. Make sure I'm looking at each one of these correctly. I'm not really going to zoom this up because you don't really need to. But just you can kind of see the grade percentages and they're listed here. Alright, so I'm supposed to impress upon you that due dates vary throughout the week, so check the MyTFC course frequently so that an assignment deadline is not missed. From what I understand, this professor is also pretty strict on deadlines, so he's not going to just be like, oh yeah, you can just make it up next week, so make sure you don't miss the deadline. So, you got to cover threaded discussions weeks 1, 2, 3, 5, and 7. Exam week, exam weeks 4 and 8, we just went over this, so I'm going to go and skip these. Let me see, make sure I'm just going to science systems. Okay, oh yeah, so here's one note that is important. So, briefly review the assignments, but ignore due dates in grade link. So the grade link due dates may not match up with your college due dates, so pay attention to the college due dates. Those are the grades you're worried about, because basically what I'm going to do is take those grades and put them into grade link. So don't worry about what grade link says if it does conflict with college. Okay, number 4, the moon phase project is due week 6. You will start it this week per the date on the course page. You must begin and end this project on the dates assigned. The moon phase project is a 30-day project which will observe the phases of the moon and log its position in the sky twice each day along with the times of your observations. Students must record 30 consecutive days of observations, which is 60 total. You need to download the moon phase observations assignment from the TFC course page. And again, question, has anyone been able to access that?
Yes.
No problems there? And you said you haven't tried yet, so
It's a PDF
do
file.
that. Okay.
So
Okay.
it's a PDF file, so you can download it.
Also, I put copies of the assignment schedule, the link to the moon phase on Atlanta, which I'll actually probably go over here in a check out. Yeah, we'll go over it in a bit. But I put that all on my class page, so if you need quick links to those, you've got that as well. If you need a link to anything that you don't see, feel free to let me know and I'll try to include it. I think I've got 4 currently. Okay, alright, so let's get familiar with moon terminology before you begin the project. There are 4 real phases of the moon that you will observe. Just as a fun game, can anyone tell me what they are?
Full moon.
Okay?
No moon. New moon. What's it called? The black one.
New moon?
New moon, full moon.
I'm talking about the moon, Teddy.
Moon. Alright, good guesses. Not quite. So there are 4 phases of the moon specifically that you are going to be observing. The waxing crescent, the waxing, and I hope I pronounced this right, the waxing gibbous, the waning gibbous, and the waning crescent. So you're going to notice that as the moon curves in and curves out as it fades in and fades out. So you'll learn about those. Okay, we are going to go ahead, let's see. Yep, we're going to go and show the video on the moon phases, and then we'll talk about it a little bit. I'll go ahead and take the last.
Besides the sun, the moon is the most obvious object in the sky. Bright, silvery, with tantalizing features on its face, it's been the target of imagination, poetry, science, and even the occasional rocket. If you pay even the most cursory attention to it, you'll see that it changes every day. Sometimes it's up in the day, sometimes at night, and its shape is always changing. What causes this behavior? The moon is basically a giant ball of rock 3,500 kilometers across, hanging in space. Its surface is actually pretty dark, with about the same reflectivity as a chalkboard or asphalt. However, it looks bright to us because it's sitting in full sunlight. The sun illuminates it, and it reflects that light down to us here on Earth. And because it's a sphere and orbiting the Earth, the way we see it lit by the sun changes with time. That's what causes its phases. Geometry. The important thing to remember through all of this is, because the moon is a ball and in space, half of it is always illuminated by the sun. This is true for the Earth too, and every spherical object in space. Half faces the sun, half faces away. We call the part facing the sun the daylight or bright side, and the half facing away the night or dark side. The phase of the moon refers to what shape the moon appears to us, how much of it we see illuminated from the Earth. The key to all this is this line, dividing the lit day side from the unlit night side. We call that line the terminator. If you're facing the moon with the sun behind you, you're seeing the half of the moon that is fully illuminated by sunlight, and it looks full. If you're off to the side, you see half of the lit side and half of the dark side, and we say the moon is half full. If the sun is on the other side of the moon, you're looking at the unlit half, and it looks dark. Now mind you, I haven't moved anything except our point of view here, so at all times the moon is always half lit and half dark. Remember that. The phase of the moon we see depends on from what direction the sunlight's hitting it, and the angle we see that from Earth. The moon orbits the Earth roughly once per month. In fact, that's where the word month comes from. Month and moon are cognates, words that have similar etymological histories. And in most languages, including English, the two words are very similar. The length of time we call the month is derived from the length of time it takes the moon to go through all of its phases, 29.5 days. So, to describe the phases, let's start at the beginning. New moon. New moon happens when the sun, moon, and Earth are all more or less in a line. The moon's orbit is actually tipped a bit to the Earth's, so sometimes the new moon happens when the moon is below the sun or above it. But at some point in its orbit, at some point in the month, it appears to be as close to the sun as it can. What does this look like from the Earth? The moon is between the Earth and the sun. So from our perspective, we only see the dark half, the unilluminated half of the moon. The other side, the far side of the moon, is lit, but we can't see it. It makes sense then to call this the beginning of the moon's cycle, hence the term new moon. Now think about this for a sec. Because the moon is near the sun in the sky, it travels across the sky with the sun. It's up during the day. You can only see it from the part of the Earth that's lit, which is when it's daytime. It's a very common misconception that the moon is only up at night, but it's up during the day literally just as often. At new moon, the moon stays near the sun, so it rises at sunrise and sets at sunset. This makes it extremely difficult to see. It is, after all, sitting next to the brightest object in the sky, and only a little bit of it is lit from our perspective. But not for long. Because the moon is orbiting the Earth, after a couple of days, it's moved a bit to the east. Now we're seeing it along a slight angle, and we can see a little bit of the illuminated half of the moon on its side toward the sun. The terminator, the day-night line, appears curved around the moon, so what we see is a thin, illuminated crescent moon. At this point, the crescent is still very thin, with the horns of the crescent pointing away from the sun. Note that the moon is still pretty close to the sun in the sky, just a bit to the east, rising maybe an hour or two after sunrise. But this means it's up all day, and then sets after the sun does. This is the best time to see the crescent moon, when the sun is already set and the sky starts to get dark. The moon will be low over the western horizon, and it'll set soon after the sun does. Let's wait a couple of days. Okay, now the moon has moved a bit more in its orbit around the...
I'm going to pause it real quick here, just so to keep an eye out for the terms that we just mentioned here. You've got waxing crescent, your waxing gibbous, your waning gibbous, and your waning crescent. So your crescents are going to be on either side, and the waning gibbous are going to be more toward the full moons. So basically, when it's waxing, it's starting, and waxing, it's getting bigger and bigger. When it's waning, it's getting smaller and smaller. So just keep an eye out for that.
Earth, and is farther from the sun in the sky. We see a little more of the illuminated part, and the crescent is wider. Since it's getting thicker, we say this is a waxing crescent moon. Waxing means growing or getting bigger. It's also well away from the sun now, so it's easier to spot even during the day before sunset. 7 or so days after new moon, we get to our first milestone. The moon is now 1/4 of the way around its orbit. It's 90 degrees away from the sun in the sky, which means we're looking straight down on the terminator, the moon's day-night line. It cuts right down the middle of the visible face of the moon, so it's half lit, with the sunward side of the moon visible and the other side dark. Confusingly, this phase is properly named first quarter because the moon is 1/4 of the way through its cycle, 1/4 of the way through its orbit around the Earth, even though it looks half full. So it's not really the half full moon. Astronomers prefer first quarter. So if you want to sound all astronomery, then you should call it that. But time marches on. The moon continues on its gravitational dance with Earth, swinging around its orbit. Now more than half full, we say its shape is gibbous, which means swollen or convex. Since it's getting wider, this is actually the waxing gibbous phase of the moon. It rises in the late afternoon and is up most of the night. Our next big step comes 2 weeks after new moon, when it's moved halfway through its orbit. It's now opposite the sun in the sky, 180 degrees around. The Earth is between the moon and sun, so we're looking at the fully illuminated half of the moon. This is the full moon. Because it's opposite the sun, it rises at sunset and sets at sunrise. It's up all night shining down on Earth. But again, wait a couple of days and things change. When the moon is full, it's 180 degrees around the sky from the sun. So as it continues to move around the Earth in a circle, the distance between it and the sun is now starting to decrease, even as it continues on in the same direction. As before, it keeps rising and setting later, but now it rises after sunset and sets after sunrise. If you get up early in the morning as the sun is just rising in the east, you'll see the nearly but not quite full moon setting in the west. Not only that, but we're about to go through all the phases again, but in reverse order. A few days after full moon, the lit side is shrinking. It's in the waning or shrinking gibbous phase. Then, 3 weeks or so after new moon and a week after full, the moon is once again half lit, the terminator splitting the moon's face in 2 even halves. This is the third quarter moon because the moon is 3/4 of the way through its cycle. It's a lot like first quarter, but the side that was lit is now dark and vice versa. It's 270 degrees around the sky from the sun. It rises at midnight and sets at noon. A few days later, and the moon is a crescent again, getting thinner. It's now a waning crescent. It rises just a couple of hours before sunrise and sets a couple of hours before sunset. Then, finally, we're back where we started. 1 month after new moon, the moon has traveled 360 degrees around the sky and is once again as close to the sun as it can get. It's new moon and the cycle starts up again as it has for time immemorial. An interesting thing happens if you move your perspective from the Earth to the moon. The phases of the moon we see from Earth depend on the angle of the moon and the sun in the sky. But on the moon, the angles are exactly 180 degrees reversed. At new moon, when the moon is between the Earth and sun, the Earth is opposite the sun as seen from the moon. It's full Earth. All the other phases are opposite too. So when we see a full moon, a moon dweller would see a new Earth, and so on. Have you ever looked at the thin crescent moon and seen the ghostly face of the rest of the unlit side? That's because it's not really unlit. The nearly full Earth is reflecting sunlight on the moon, lighting up the otherwise dark part. The Earth is bigger and more reflective than the moon, so it's actually 50 times brighter than a full moon. This glow is called Earthshine, a term I quite like. Even more poetically, it's been called the old moon in the new moon's arms, referring to the unlit part surrounded by the crescent new moon's horns. That's lovely, isn't it? The moon is one of the most beautiful and most gratifying objects in the sky to observe. It's different every day, yet it's also the same because we see more or less the same half of it, the same face all the time. It's big and bright, and the features on its surface discernible by eye, and even better with binoculars or a small telescope. As the phases change, inexorably, day after day, the angle of sunlight hitting the surface changes, bringing new things into our view. The motions become comforting, even familiar. It's a reminder that the universe may seem strange and complicated and forbidding at first, but over time, as you get outside and experience it, it becomes your neighborhood. Welcome home. Today you learned why the moon has phases. It's a sphere and it orbits the Earth, so the angle at which we see its lit side changes. It goes from new to waxing crescent to half full, waxing gibbous, full, waning gibbous, half full, waning crescent, and then the cycle starts all over again. This also affects when it rises and sets and what we see on the surface. Crash Course is produced in association with PBS Digital Studios. This episode...
So, I believe I put a link to that video up on my class page. Yes, thank you very much. So if you need to watch this again, I totally understand a lot of terms to kind of like memorize. It's not too hard, but definitely you just need to like have several terms memorized. So you will be observing it. Now, moving, any questions about this, by the way, this video? Alrighty. Okay, so in this case, you will not observe the moon at the same time every day. You probably saw something on that in your assignments in college. Moonrise and set times vary each day. The phases last for 7.375 solar days each. To complete the project, you will need to make your observations when the moon is visible, so you need to know when it rises and sets every day. So if you want to know that, and I believe I put a link up on my thing for it. Let me see here, moon phases. You can go to this website. It is Atlanta Moon Phases, and it will actually tell you, you can actually look at this, you'll see, it'll tell you what percentage it is, it'll tell you what state and phase it'll be in, so that ought to help you with your assignments. It basically gives it what it's going to be. It'll tell you what dates that they're going to be, which moons. It'll also tell you what times exactly. You'll see 3:31 p.m. on October 16th, it's going to be a new moon. 9:22 a.m. in the morning, October 23rd, first quarter, you'll be able to see the moon at half. So basically do your very best to try to pinpoint those times. I understand with being school and college, all that, you may not have immediately ready available. Now, I can ask Ms. Gaskins, depending on the day, if y'all need to be out real quick to kind of observe the moon, like during class, I'm fine with that. You might talk to your teachers about that as well and see if they'll let you do that. But yeah, so if we need that, you can go to this website. It's really good. Okay, let's see. See, it says if possible, we should go out and observe the moon as a class. So tell the class, let me see what day it is. Today is October 20th. According to that, at 9:42, it says the moon is at a waxing crescent, first quarter. We could try and look for it. So we can pause our recording, go out real quick, and look for, see if we can see it. So let's do that. I'm gonna